Yes, welcome to DC Economics. So today I'm going to take you on how we can calculate coherently about expected mean of discrete random variable. So what we need to understand first, we need to understand the meaning of discrete random variable before we enter into calculation. So a discrete random variable is the one which may take only a countable number of distinct values such as 0, 1, 2, 3, and 4, and the usual count but not necessary. So if a random variable can take only a finite number of discrete values, then it must be discrete. So what about discrete and random variable? Let's look on random variable. So the two concepts between the discrete random variable and random variable is that random variable, this is a variable that takes on the difference of numerical values determined by the outcome of a random experiment. What is expected value? The expected value, this describes the long-term average level of random variable based on its probability distribution. So here we are going to look on how we can find the expected mean. We are going to look on how we can find the expected mean on discrete random variable. So in investing, the expected value of a stock or other investment is an important consideration and is used in this scenario analysis. So for example, find the expected value, mean, variance, and standard deviation of the following two fair dice are tossed. So there are two dice that are tossed. This means that the total two dice consist of 6 times 6, which is 36 number of some elements on those dice. So we have the x and probability of x, as you can observe, 2 up to 12, and probability of x is 1 over 36 up to 1 over 36, as you can observe. So from this kind of data, we are required to calculate the expected value. So we begin like this. So from a probability, the expectation is given by taking summation of x times probability of x. So the summation of x is where we take out our values of x, we times the probability of x, that is 1 over 36. So it will be, we take out 2 times 1 over 36, plus 3 times 2 over 36, plus 4 times 2 times 3 over 36. Then times, we take out again 5 times 4 over 36. We take also 6 times 5 over 36 plus 7 times 6 over 36, then plus 9 times 4 over 36, times 8 times 5 over 36 plus 9 times 4 over 36, then plus 10 over 3 over 36, then plus 12, plus 11, that is 2 over 36, and plus, we take out 12 times 1 over 36, as you can observe. So we make summation on summation of x times probability of x. So this will give out the expectation of x will be equals to, the expectation will be equals to 570 over 81. It's like to say it will be 5.8641975 and 31. So that will be our expected value. So the expected mean, the mean value, would be equals to, when we take out the summation, it will be 5 over 72. So it's like you say, when we put it in a proper fraction, from complex to simple fraction, this will give out 409 over 72. So the expectation of x, the mean values of x, will be equals to 509 over 72. So that will be. Now let's come to variance. So the variance of x is given by taking the expectation of x square minus expectations of x bracket square. So since we have the value, the expected mean, we have the expected, we have the expected mean. Now we need to find only the expectation of x square. That will be taking the summation of x square, will be summation of x square times probability of x. So we need to demonstrate another table. We need to establish another table for x square, so as it can be simple for us to obtain the summation of x square times probability of x. So let me lab over here. So let's develop out the new table for x squared. So we develop another table over there. So we find out the values of x squared is where we times square on the values of x above. So this will be x squared. So let you times 2 times 2, that's give you 4. 3 times 3 is 9. Take 4 times 4 in the upper bar will give you 16. 5, 25. 6 times 6, 36. 7, 49. 8, 64. And 9 will be equals to 81. 10 times 10 is equal to 100. That will give you 100. And 11 times 11 is 121. And 12 times 12 is 144. So the valence of x will be equals to taking summation of x squared, expectation of x squared minus expectations of x squared. So let you find the values of expectations of x squared. They will be given summation of x squared times probability of x. So let you take the x squared and times with the probability. So it will be 4 times 1 over 36. So the expectation of x squared would be equals to 4 times 1 over 36. So we take out 4, which is the x squared. That we take out 4 times 1 over 36. Then plus, we take 9 times 2 over 36. We take out also, we plus out also 16 times 3 over 36, as you can observe. So we take out all the values of the x squared and we times with the probability. So here it will give you 2 over 36, then plus it will be 16 times 3 over 36, then plus 4, that times 25 times 4 over 36. We take out 36 again times 5 over 26, then plus 49. 49 times 6 over 36. And we take out 64 times 5 over 26. We take out again 81 times 9 over 36, 4 over 36, then plus, we take out 100, we take out 100 times 3 over 36, bracket, then times, plus 121 times 2 over 36, then plus 144 times 1 over 36. So let's use sum. So when you use your calculator to plug in the values, you will obtain out the expectation of x squared will be equals to. Remember here, we have not found the variance. We are still in the process of finding the variance. So the answer here will be 56 14 over 30. So since we have the value of x squared, expectation of x squared, now it is easy now to plug into the formula for variance. So let you plug to the form of variance to obtain our variance. So when we put into a simple fraction, it will be 1699 over 30. So after taking that, let you plug into the formula so as you can obtain the actual value of variance. So variance of x will be expectation of x squared times expectation of x, then raise of square bracket square. So let you plug in the values of expectation of x squared, that is equal to, remember we found that the expectation of x squared is equal to 5619 over 30. So we plug in 5619 over 30. So we minus, we take out the expectation, the mean value, the expectation mean that we found it earlier. That was, we obtained the expectation mean was, it was 75 over 72. So take out 75 over 72. Then you plug, then you will square it. Then so the balance of x will be equals to 5619 over 30 minus 75 over 72 square. So the answer will be equals to 6.6568, then 58. So that will be the balance. So the balance of x will be equal to 6.7 when we approximate it in a normal way. So it's not the case we approximate it. Let us leave it as it is. You can observe. So that is how we find out the expected mean on a discrete continuous random variable, on the discrete random variable. So if we find the standard deviation, we actually square root the variance. So the standard deviation will be equal to the square root of variance. That will be equal to 6.656288858. So the standard deviation will be equal to, when we put the square root over there, the answer will be equal to 2.57997847. So that will be the answer of the standard deviation. So let's mark at our end. Welcome to DC Economics. Bye bye.